Great secondary students, last week we learned about binary to denary number. So we learned how to convert that by, let's say, we go on to the binary and the denary number that we want to convert that. So binary to denary number, we have learned with using the two table or multiplication of two conversion table. Just 1, 2, 4, 8, 16, 32, 64, and 128. So that table gives us an easy conversion if we want to know the binary numbers of 0, 0, 0, 1, 1, 1, 1. And we've learned that if the table has one value, we're going to take all the numbers that has the one value and group them up together and add up the numbers. So 8 plus 4 is 12, plus 2 plus 1, and then we have the numbers all added up together is 15. How do we convert denary to binary? All right, in our textbook, there are two methods. I'm going to show you the first method, and we're going to have a denary number of 75 first. Now, the first method is division by 2. We're going to write 75 right here. We're going to write a box right here so that we can divide it by 2. Now, what will be 75 divided by 2 be? So, if we do the calculation correctly, 75 divided by 2 will be 37.5. But we don't write the remainder directly. We just make sure that we write down 75 and the remainder we write this as 1. That means there is a binary value of 1 at the end. Then we're going to divide 37 by 2 again. And if you did it correctly using the methods shown on the right, if it divided correctly, that will be 18.5. There is a remainder, but we don't write that remainder in the box. Instead, we write 18 right on the bottom. And 18 divided by 2 is definitely 9, so there is no remainder. So we're going to write that as 0. And we'll write 9 just right below there. Now, if you divide 9 correctly, there is definitely going to be a remainder. And this will be 4.5. And instead of writing 4.5, we write the remainder as 1. And then we have 4 right below 9. And then 4 divided by 2 definitely is 2. And 2 divided by 2 is definitely no remainders. So in the end, all these values together, you can rewrite the binary into this way. The numbers, the top number will be placed at the most right, which is 1, 1, 0, 1, 0, 0, 1. Now, this is only 7-bit numbers, and the last one, you can put it as 0. So the denary value, the binary value of 75 is 0, 1, 0, 0, 1, 0, 1, 1. Method number 2 allows you to use the conversion table, and you can write this out like this. Now, put this 75 somewhere so that you can see, and then we're going to compare using the table. Now, method number 2 starts on the left. Now, take 128 and compare it to 75. At a glance, 128 is definitely higher than 75. So we're going to put the 0 because we're not going to use this number because 128 is higher than 75. At a glance, 64 is within 75. So we're going to go ahead and put the value number 1. We're going to put a value in 64 and going to write down 64 right at the bottom. Now 64 plus 32 is definitely higher than 75. And we're not going to use this number because when you add that up together, it will be 96. And 96 is definitely higher than 75. So we're not going to use 32. What about 16? So we're going to carry forward 64, and 64 added up with 16 is 80. 80 is definitely higher than 75, so we're not going to use 16 as well. What about 64 plus 8? This will be 72, and 72 is within 75, so we can go ahead and put 1 under the table, and let's carry forward to 72, because we're going to use that. 72 plus 4 is 76, and that's definitely over than 75. So we're not going to use 4, and we're going to put that as 0. And then 72 plus 2 is 74 within 75. So we're going to put that value, and 74 plus 1 is 75, which is exactly the value. So method number 2 allows you to use the conversion table and find out the binary values that you needed. Let's say I have 20. How do I convert 20 to binary? I'm going to use method number 2 using the conversion table 1, 2, 4, 8, 16, 32, 64, and 1 to 8. Now, comparing the number 20 is definitely smaller than the numbers at the front. So 1 to 8 is definitely 0, 0, 32 is also 0, but 16 is within 20, so we're going to put 1 over there. And the 16 plus 8 is definitely smaller and over 20. And 16 plus 4 is exactly 20, so we put that value, and the rest will be 0. Let's try one more. This time, we're going to use another number, and let's say 14. Let's try out method number 2 again using the conversion table. 16, 32, 64, and 1 to 8. Now, at a glance, 14 is definitely smaller than 1 to 8, and 64, so it's going to go ahead and put 0 in these values. Now, 32 is with 40, so we're going to put 1 there. 32 plus 16 is definitely higher than 40, so we're not going to use 16. 32 plus 8 is exactly 40, so we're going to put 1 there, and the rest will be 0. So the binary value of 40 is 00101000.